The next step is turning all that raw information into something we can use to make predictions. This is where the data modeling pipeline comes into play. The primary goal of these models is to predict how your body will react to a meal. We measure this reaction with a metric called the incremental area under the curve, or IAUC. You can think of it as a way to quantify the spike in something like blood sugar after you eat. The better we can predict that spike, the better our nutritional advice becomes. This pipeline is a bit like a four-step recipe. First, you have the raw ingredients, all our deep phenotyping data. Then you prep those ingredients, cleaning and processing them. Next, and this is important, you select only the most relevant ingredients or features. And finally, you combine it all using machine learning to create the prediction. That third step, feature selection, is absolutely essential. With hundreds of data points for each person, we need a way to filter out the noise. Feature selection helps us identify the data points which are most predictive, like visceral fat, for instance, and ignore the ones which aren't. This makes our models more accurate and more efficient. So in the final stage, we take these carefully chosen features and feed them into machine learning algorithms. This is how we build the actual predictive model. Two types of algorithms have been especially useful for this. Random forests are great because they can handle all the different kinds of data we're working with, from clinical measurements to survey responses.